All right, so what we're going to do now is we're going to take these equations that we've been kind of haphazardly applying to things and try to make a little bit more sense of them. This is just a totally different way of thinking about it. So we're going to try and take these equations and kind of put them into the circle format, which actually makes it a little bit easier to see. So we're starting with these two things, which we already know already. Then what we're going to do is we're going to square both sides of both of these sets of equations. And I will show you what that looks like. It's actually pretty cool. And this is what you get. So now what we're going to do is we're going to take this equation, and we are going to add them together because you can kind of see that some stuff's going to cancel out. So let's take this thing, and I'm just going to move it down here. Whee! Okay, and line up my little equal signs. And if I put a big giant plus sign underneath here, first of all, you're going to see immediately that these are going to cancel out, which is kind of neat. And then from there, you've got some common terms and you can combine things like that. Okay, and without too much trouble again, hopefully you recognize that that can be simplified to 1 and that could be simplified to 1. So we just end up with this. Yay! Okay, now the funny thing is that what we're actually going to do is we are going to take all of this here and we're just going to call that r squared. So that essentially what we're able to do is if I pull this away, I'm just going to call that thing r squared, which means now I have an equation that this is equal to r squared. So see how beautiful and pretty and amazing this equation is? Even though, like, because it's like, oh, look, it's just r, except that, like, r is secretly this thing down here, or r squared is secretly this thing down here. So, I mean, it's not actually that pretty. But it's a little weird, but basically we're going to go with it. And the reason we're going to go with it is this is the equation of a circle, right? And so the circle has a center, if you remember this from, like, high school geometry, hk. So this would be like x minus h squared plus x minus, y minus k squared is equal to r squared. And so that means that the center of the circle is at the point h comma k. The center is at h comma k. In this case, our h is sigma average, and our k is actually 0. So our center is at the 0 average. And the axes, instead of being x and y, are given by sigma x prime and tau x prime y prime. And then the radius is the square root of r. Okay, and so I'm going to show you what that looks like on a piece of paper. Okay, so I'm going to put this circle onto an axis. One of the first things you're going to notice is that we are putting this down here, and that's kind of what we have to do to make the math work or to make the picture work. We'll get into that. But basically, we've got a circle, and right here at the center is where the center of the circle is, which is, remember, at that average point. So the center of the circle is given here at sigma average, okay? And it's got a radius of r, whatever that big giant number is going to end up being. Okay, so a couple of things to think about as you're looking at this. So our principal stresses are going to be where the tau x prime y prime is equal to 0. So that means that for sigma 1 and sigma 2, we just need to look right here on the axes, and sigma 1 is always greater than sigma 2. So we can see that immediately from looking at the picture. And that also means that what we have right here is our principal axis. Okay? Now, the original stress, so if we're kind of wondering where we came from, the original stress is where we are on the circle, where on the x prime y prime axis, the tau x prime y prime axis, where we would get the value of the original tau xy. So what that means is that we've got the sigma x prime minus the sigma, let me make that prettier so you can see it, the sigma x prime minus the sigma average that would need to equal the sigma x minus sigma y divided by 2. Okay, and so we can solve that and get, let's see, and then if I put the average on the other side, then let's see, sigma x prime would be the sigma x minus sigma y over 2, but then if I add plus sigma x plus sigma y over 2, the sigma y over 2's cancel out, so I just end up with sigma x again. So basically what that means is there's specifically a point somewhere here, and I'm just kind of picking this one arbitrarily. This isn't a specific point because I don't mean real numbers, but essentially what you'd have is a point right there where you'd have the values sigma x, tau, xy, like that. And then the last thing that you would want to do is look and see, okay, so where are we specifically with respect to that, the angle to the principal axis. So let me move this label over here, and then what I'm going to do is I'm going to draw this angle in right here, okay? And so this coming up to here, that's going to be twice the principal axis, okay? Okay, cool. So that's how you can get that theta value from looking at the circle. And then finally, your max value of tau x prime y prime. So the max value of that is just going to be at the bottom of the circle. And that's pretty, I mean, because that's where, remember, because positive goes down, so the max is just going to be at the bottom of the circle. So essentially you would find the sigma and you go straight down because they're the same thing. So, so that's how we would find where that occurs. It's at that point occurs, the max x prime, tau x prime y prime occurs at the point sigma average tau x prime y prime max. So basically the idea is with the Mohr circle, you've got all of this information in one place, and all you have to do is kind of look a little bit of math to set it up. But it's ideally supposed to be this like visual way of picturing what's going on with the stresses and the such on the little piece of material or whatever it is that we're looking at.